to Advent of Code 2025, Day 3, Lobby. You descended a short staircase, enter the surprisingly vast lobby, and are quickly cleared by the security checkpoint. When you get to the main elevators, however, you discover that each one has a red light above it. They're all offline. Sorry about that, the elf apologizes as she tinkers with a nearby control panel. Some kind of electrical surge seems to have fried them. I'll try to get them back online soon. You explain your need to get further underground. Well, you could at least take the escalator down to the printing department. Not that you get much further than that without an elevator working. That is, you could if the escalator weren't also offline. But don't worry. It's not fried. It just needs power. Maybe you can get it running while I keep working on the elevators. There are batteries nearby that can supply emergency power to the escalator for just such an occasion. The batteries are each labeled with their joltage rating, a value 1 to 9. You make a note of their joltage ratings, for example, like here. The batteries are arranged into banks. Each line of digits in your input corresponds to a single bank of batteries. Within each bank, you need to turn on exactly 2 batteries. The voltage that the bank produces is equal to the number formed by the digits on the batteries you've turned on. For example, if you have a bank like 1, 2, 3, 5, and you turn on batteries 2 and 4, the bank would produce 24 joules. You cannot rearrange batteries. You need to find the largest possible voltage each bank can produce. In the above example, 9.8, you can make the largest voltage possible, 9.8, by turning on the first 2 batteries. Each line. Okay, so we find 2 numbers, put them together, and that's the highest one. In this one, 9 to the largest voltage you can produce is 9 to. And then we have a total. Okay, so for each line, I should have done this. For each line, I would say kind of try to find a high number like 9, and then find a high number right of that. Or we can map it to digit to int. Let's get the highest maybe. Or maybe numbers. Highest is numbers dot index of or max. The highest is maximum. And then we say highest index is here we go, index of first, which is highest. And then we go numbers, drop these one, no, drop highest. Drop the first one highest, and then we find it again highest. This can find highest index, next highest, or let's say second. This is a second index. We know what we're doing from the rest. Let's return both. Then we just have a pair of index and the actual number. And then we have second index, second highest. And then we just have second highest. Then we can map that. Maybe like sum it or something like that, right? Let's see. Total. Let's check here. We have 3 by 7. Interesting. Because here I got 8 from the end, and here I probably also got 9. I can't take the latest. Let's see. I can probably, and then I can take the latest. 365. Let's just check the numbers. 99. Okay, so I got second one again somehow. Numbers is this. Okay, I need to drop one more. Okay, now we're at 357. See if that works. And that's correct. For part 1. The escalator doesn't move. The elf explains that it probably needs more joltage to overcome the static friction of the system and hits the big red joltage limit safety override button. You lose count of the number of times she needs to confirm yes. I'm sure. And decorate the lobby a bit while you wait. Now you need to make the largest joltage by turning on exactly 12 batteries within each bank. The joltage output for the bank is still the number formed by the digits of the batteries you've turned on. The interface that now there will be 12. So now you can turn these on, or 91109. That's the same, but with 12. The tricky part is just that, yeah, how do we drop? Because you always have to drop enough at the end of the list so that the rest of the list can still have enough numbers. If we need to drop, let's just do everything again. I think we need to drop 11 for the first round. And it would also be nice not to have to write it 12 times. Do something like hmm. Let me go. Somehow we do this 12 times. And the result, something like that. So first, we'll start with 12. We have to go. Then we have 11. We can do C here. Get the highest. Index 0. We have to kind of drop from the beginning. We need something like 10 to the power of C. Power 10 to C. Hmm. n to double. Oh, maybe I can do these have to be double. Maybe this works. Okay. Something like that. And then the index needs to be, this one's always the highest index and it always moves to the right. Find the highest number from a list of numbers, except for the last C in that list, and except for the first. Now drop the index. I think I need index plus 1 though. Need to just update index, highest index. And then after I'm done, I map n here. Let's see what happens. Interesting. Let's see. The first row. I'll go through it. Let's see what happens. Start with this line. And then we start 12, 0 minus 1. Go down to 0 to C11. So I drop 0 and 11 at the end. Let's see what that is. So I only have 9, 8, 7, 6 to choose from. Get the highest index. That's fine. Because I dropped from the beginning, I have to watch out though, because I'm going to offset my index. Maybe I need to just change it here. Maybe I just put the offset in here and then I can offset it. Plus offset. And I put the same offset I'm adding here anyway. Well, which is IDX plus 1. That's my offset from the numbers. Did I get the right index? I don't care about the end because the end can drop away, but I still want to, based on the start of the list, have the right index. Let's see what happens now with the result. Does this use it correctly? Okay, so if this, these numbers are also quite long, quite big, so going to make everything a long. Instead of n too long. Okay. Now we got this. What do we have here? 8, 6, 90. That looks good. Let's see with the real example. And that's it. For day 3, let's walk through it. So first we want 2 numbers in each row that would combined give the biggest number. So it's 98 here. So, and it's 89 here. So the idea is get the biggest number and then get the second biggest number right of that in the list. So 90 is always bigger than 80, so I can never start with 80. So I always get the biggest number and then take the rest of the list and get the next biggest. That's what we do here. We get the biggest from everything except for the last one, because I had this bug where if you pick 9 first, then you don't actually know how to finish the number because you have to look on the right of that list. So I drop one from the numbers, find the highest, then I take the right side of the rest of the list after my current number, and then find the second highest. And then I can do highest times 10 plus second highest, sum them all up, and then we have part A. Part B, we do the same. We just rewrite it in a way that we can do this part in a loop. So the first number is highest times whatever, 1 billion or trillion, something like that. So we build this number with 10 times power 2. And to the power of c, where c is 11, the beginning, so 12 minus 1. And then you have first loop, highest times 10. And the next loop you have this much and this much and this much. And then every digit goes to its separate place in the number. So when you build a number like 9 plus 8 plus 7, every digit has a different amount of zeros, and that's how you can make a number like this. So we can do that in the loop with the C, looping down from 12 to 0. And then we can reuse C, looping down from 12 to 0 by dropping the last C elements, which is what we did here. We dropped 1 because we needed 1 more space. We choose one number, and we need 1 more space to be able to choose the next one. Same way we need 11 spaces here to choose the next 11 numbers for the first round and so on. Then we just fetch from the list after the highest index always. And yeah, leaving space to so we have enough space for the end to find more numbers. And then we can just add them all up and sum them up. And how find highest works is we get the highest by figuring out what's the largest number in the list, and then we find the index of the largest number, so we can also do this. Let me do it twice anyway, because we want to keep track of it. What's the highest and where is it? So then we find it where it is in the list by getting index of the first one. That's the highest. And then we add the offset because we dropped here from the beginning in some cases. We want to re-add the offset again. So the number we drop, same number we offset. And that's it for day 3. Enjoy the rest of your day.